Hello, today I will solve 10 tricky quantum harmonic oscillator MCQs with deep explanations and exam rules so you don't fall into common traps. Question 1. The ground state energy of a one-dimensional quantum harmonic oscillator is option A 0, option B half, h cut omega, C h cut omega, D 3 by 2 h cut omega. And the correct option is option B half h cut omega. Explanation. Basically, a particle at rest has zero energy. But in quantum mechanics, Heisenberg's uncertainty principle does not allow both position and momentum to be zero. Therefore, even in the low state, the particle must have some energy called zero-point energy. You must remember exam rule. For any harmonic oscillator, ground state energy is never zero. If option 0 appears, just eliminate it. Question 2. The spacing between adjacent energy level is option A increase with n, B decreases with n, C constant, D random. Correct option is answer C constant equal to h cut omega. Explanation. Energy levels follows En equal to n plus half h cut omega. If you want to count the spacing, En plus 1 minus En equal to h cut omega, this is always the same. Unlike the hydrogen atom where spacing decreases with respect to n. You must remember exam rule. Harmonic oscillator goes to constant spacing. Don't confuse with atom model. Question 3. For any stationary state, expectation value of x is option A positive, option B negative, option C 0, option D depends on n. And the correct option is answer C 0. Explanation क्या है? The potential is symmetric about x equal to 0 and stationary wave functions are symmetric or antisymmetric. Hence, probability distribution is symmetric and average position is 0. Exam rule. For any symmetric potential, expectation value of x is equal to 0 in stationary states, not just harmonic oscillator. Question 4. For the ground state, delta x into delta p equals option A 0, option B greater than h cut by 2, option C equal to h cut by 2, option D equal to h cut. And the correct option is answer C h cut by 2, that is equal to minimum. Ground state is a Gaussian wave function. Only harmonic oscillator ground state and Gaussian wave packets achieve minimum uncertainty. Exam rule. Only harmonic oscillator ground state and Gaussian wave packet achieve the minimum uncertainty. All other have delta x into delta p greater than h cut by 2. Question 5. The ground state probability distribution is option A uniform, option B linear, C Gaussian, D exponential. Ground state wave function equal to A exponential of minus x square over 2 sigma square. Probability is directly proportional to exponential of minus x square. which is a bell-shaped curve. Exam rule: ground state harmonic oscillator always Gaussian shape. Question 6. Expectation value of momentum. Question A: for any stationary state of a harmonic oscillator, expectation value of P is option A 0, option B non-zero, C maximum, D undefined. Correct option is option A 0. We have momentum operator equal to minus iota h cut partial d by partial x, For symmetric potential with symmetric antisymmetric wave function, the integrand is odd, means integral is equal to 0. Expectation value of P equal to 0 always. So the exam rule: any bound stationary state delta P equal to 0, not just harmonic oscillator. Question 7. What is the energy of the third excited state of the harmonic oscillator? Option A 3 by 2 h cut omega, option B 5 by 2 h cut omega, option C 7 by 2 h cut omega, option D 9 by 2 h cut omega. Energy formula for the harmonic oscillator equal to n plus half h cut omega. Ground state n equal to 1, not. Ground state n equal to 0. First excited n equal to 1, second excited n equal to 2, third excited n equal to 3. So E3 equal to 7 by 2 h cut omega. Always remember ground state n equal to 0, not n equal to 1, and this is a common trap. Question 8. The classical turning points occur where option A psi equal to 0, option B kinetic energy equal to 0, option C potential energy equal to 0, option D momentum is maximum. And the correct option is option B kinetic energy equal to 0. At turning points always occur where kinetic energy equal to 0, not where wave function equal to 0. You have to remember, turning points are those where kinetic energy equal to 0, not where wave function equal to 0. Particle momentarily stop but bounces back. Question 9. Which operators lowers the energy state by 1 quantum? Raising operator, lowering operator, X operator, P operator. As the name indicates, option B is correct, lowering operator. Question says lower, answer is A dagger. The lowering operator, A operator, not A dagger. Question 10. For the ground state, expectation value of x square is proportional to option A h cut by m omega, option B h cut by 2m omega, C m by h cut omega, D 0. Option A is correct, h cut by 2m omega. Note, larger mass goes to smaller spread. And what is the exam rule? You have to remember, higher frequency equal to stronger confining potential, and this is equal to smaller expectation value of x square. Thank you. If this video helped you avoid exam trap, like and share it. कमेंट करें कौन सा MCQs सबसे मुश्किल था. I will solve more tricky physics question in the next video. Thank you. Allah Hafiz.